basically what's going on here is you're going to have an equation. It's going to have a radical symbol in it. You're going to have x's underneath the radical symbol. And here are, I'm going to start with a quick bit of notes and then examples. So here's the notes portion of this video. And that's it. Okay, if you want to get rid of a radical symbol, which is what we're trying to do. When you solve an equation, you're getting rid of all the things that have been done to x. If x has had 2 added to it, you subtract 2. If x has been divided by 4, you multiply by 4. You undo all the things that have happened. So if x has been square rooted, you need to square it. And for that to happen, you need to get a radical all by itself. And then you're going to square both sides. And the reason that my friends are here is because if you isolate a radical, it might just have an x under it, it might have an x minus 1 under it, or whatever. Whatever is on the other side of the equation, when you go to this next step, needs to get squared. So I square this, and x minus 1 equals goat squared. So x would equal goat squared plus 1. No big deal, right? The one that might cause you some issues if you're not careful, let's say we have the square root of x plus 3, we've isolated the radical, and that's equal to gorilla plus goat. Okay, to solve this, we square both sides, because you isolate the radical and square both sides. Or cube both sides, or raise both sides to the fourth, whatever. Most of the time, 99% of the time, it's squaring. The reason is because the square root and the square cancel, and I'm just left with x plus 3. Now, this is not gorilla squared plus goat squared. And I say this lots of times, but people still make this mistake. This is gorilla plus goat times gorilla plus goat, which would be gorilla squared plus 2 times gorilla goat plus goat squared. All right, you got to FOIL it. You cannot just distribute that square. That's a big no-no. It's the first one squared and the last one squared, but in the middle you've got 2 times the first one plus the last one. That's the pattern that happens when you FOIL stuff. All right, when you FOIL a binomial, when you square a binomial. All right, so this is obviously just a silly example, but you get the point. Whatever you do, whatever you have on one side after you isolate the radical, square it all. Sometimes you can get out of it in one step, sometimes it's going to take a couple steps. So let's do a couple examples. Do a one-stepper and then a multi-stepper. Number 1, let's try this. X plus 5 is equal to the square root of x plus 5 plus 6. Okay, so the one and only note of the day is to isolate the radical. So let's do minus 6. X minus 1 is equal to the square root of x plus 5. Okay, so the radical has been squared, or isolated, and now we need to square both sides. So this side is x minus 1 squared. This side is x plus 5. This left is not x minus 1 or x plus 1. It's x squared minus 2x plus 1. Don't distribute that square, please. That's equal to x plus 5. Now, what happens in this step, as we talked about a little bit in class, when you do a fractional equation and you get rid of the denominators, you get rid of the chance to have a 0 in the denominator. When we square both sides, we get rid of the chance to have a negative number under the square root. So what happens is you get extraneous solutions from time to time. There are not very many in your homework set, but you just have to check them anyway. So this turns out to be a quadratic equation. So whenever you have a quadratic, you get 0 on one side. So I'm going to move my x to the left and make it negative 3x. And I'm going to move my 5 to the left and make it negative 4. And this is equal to 0. And with a quadratic, if it factors, that's good. If it doesn't, we use the formula. This one is going to factor x minus 4, x plus 1. Quick double check. Minus 4 plus 1, yeah, good. So my two answers are x is 4 and negative 1. So if those two values make the original true, I've solved it. That's what it means to solve, to make sure it makes the original true. So let me check 4 real quick. If I check 4, I get 9 on the left. I get the square root of 9 plus 6. 9 is equal to 3 plus 6. So 4 works. Let me check negative 1. All right, checking negative 1, I get 4 on the left. I get the square root of 4 under the radical plus 6. So does 4 equal 2 plus 6? Obviously not. So negative 1 is out. It's an extraneous solution. So 4 is my solution. Negative 1 is not. I just said a minute ago that it doesn't happen very much. It might happen more than I was thinking at the time that I said that, so definitely check them all. So this one was a relatively easy one because you isolated the radical on the right and you squared, and there wasn't anything too crazy. We got rid of all the one and only radical when we isolated and squared. Sometimes you cannot get rid of them all, and here's an example of that. I'm going to take the square root of x minus square root of 7 is equal to square root of x plus 7. So everything in here is a radical. So obviously you can't just isolate one and have nothing on the other side. So we do have one of our radicals isolated. So we can just start right here and square both sides and at least get rid of this one over on the right. Remember, goat and monkey. So remember back here, you cannot just do x minus 7 on the left. That's a big no-no. I have to write it twice and FOIL it. If you can FOIL it without writing it twice, good for you. If not, write it twice and FOIL it. This side's going to be x plus 7. So that's one good thing. I've gotten rid of the radical on the right. So over here, I FOIL. I get x minus radical x times radical 7, which is a radical 7x, minus radical 7x plus 7. Okay, so putting that together, I get x minus 2 times the square root of 7x plus 7 equals x plus 7. And now I have some stuff that'll cancel. So let's see. This one's, they're not all going to be this way, but what I would try to do is isolate the next radical. My one note of the day is isolate the radical. If you do that and square and you get another radical, well then isolate that one. So if I subtract x from both sides, I just lose my x's. Subtract 7 from both sides, I lose my 7's. And I'm left with negative 2 times the square root of 7x equals 0. All right, and so in order for this to be true, x would have to equal 0. All right, I can divide by negative 2 and then square and all that, but really, if this is going to equal 0, the only way that can happen is if I take the square root of 0. I'll do those steps anyway. All right, square both sides and you get 7x equals 0. Divide by 7, x would have to equal 0. Okay? So the one answer I have is 0, and I need to check it. I got confused for a second because I adjusted my original. My original is square root of x minus square root of 7 equals square root of x plus 7. So if 0 will work for this, then I'm in good shape. So I plug in 0, I get negative square root of 7 on the left, and I get positive square root of 7 on the right. So 0 does not work, which means that no solutions, empty set, however you want to say it. There's nothing that can make this true. All right, so that's a unique finishing on that one, but the point's the same. Get one radical by itself, square both sides. If it turns out that you have another radical when you do that, like we did right here, well, then isolate that one and square. And you might have to do it 2, 3, 4 times, but just keep isolating a radical and squaring. And that's it. And that's radical equation. All right, so I will see you in class. I hope you've enjoyed 8-4, Young out.